The applications of GD&T self-paced online training is designed to help you build on the fundamentals of GD&T and confidently apply the ASME Y145 standard to real-world drawings. This course focuses on practical application, helping you improve datum selection, create more robust designs, and better communicate design intent across engineering, manufacturing, and inspection. Like all Tec-Ease training, the course supports multiple learning styles through clear graphics, animations, videos, closed captioning, and a bit of humor to make complex topics easier to understand and remember. The lesson you're about to see is taken directly from the course and provides a snapshot of how the training works and how the material is presented.
For our second example, the part, which looks a bit like a snowman with a tilted top hat, has a shaft that fits into the 30 mm diameter bore, which is datum feature A, and another shaft that fits into the 18 mm bore, which is datum feature B. Since datum feature B can be located relative to datum A, a position tolerance needs to be applied to datum feature B. That works fine for the location control needed, but the orientation of this hole's feature axis must be controlled more tightly than the 0.3 mm cylindrical position tolerance zone will provide. So let's tighten up the orientation only with this parallelism of diameter 0.1. For the position tolerance and the refining parallelism tolerance applied to datum feature B, the controlled feature element is the feature axis. It's a good time for a reminder. A feature axis is defined as the axis of the feature's unrelated actual mating envelope. For the cylindrical hole in this example, the unrelated actual mating envelope is a maximum inscribed cylinder. The position tolerance zone is located relative to datum axis A by the 30 mm basic dimension. This tolerance zone controls the location and orientation of the hole's feature axis. The parallelism tolerance zone is a cylinder with diameter 0.1 mm that is orientation constrained relative to the datum reference frame A, or we could also say relative to datum axis A. The parallelism tolerance zone will refine the orientation of the feature axis to diameter 0.1 mm. To illustrate how the orientation refinement provided by the parallelism tolerance works, we will watch another video. Like the last video, the feature's imperfection of the hole is exaggerated, and the tolerance zones are shown much larger than scale. Here is the part, and we will zoom in on the hole to see the unrelated actual mating envelope that is pink in color. Now let's add the feature axis at its center. Next, we add the position tolerance zone, which is this red cylinder that constrains the location of the feature. We can see in this view that the black line that is the feature axis is within the position tolerance zone. Now the blue orientation constrained parallelism tolerance zone appears. And from this view, we can see that the tolerance zone can be moved to a location that makes it fit around the feature axis. So we have another in-spec feature that has been illustrated. The feature axis is the controlled feature element, and it meets the position tolerance and also the orientation refinement that is provided by the parallelism tolerance.
What is the purpose of applying a parallelism tolerance of diameter 0.1 mm to datum feature B in this example? No, this is what the position tolerance does. Remember, the parallelism tolerance is a refinement. Great job! The parallelism tolerance adds a tighter orientation control, diameter 0.1 mm in this case, relative to datum axis A. The position tolerance still controls location, while parallelism tightens up orientation only. Great job completing that activity. Click the next button to continue with the course.
To purchase the applications of GD&T self-paced online training, visit www.techease.com/store or call 716-785-6015. Individual and corporate concurrent subscriptions are available.